What's up? So today we will look into this binary called str.exe. So first I will show you what happens when you simply run this binary directly. As you can see, it is showing a dialog box from where user can enter a password and it will simply check it. So when you click on the check button, it is showing wrong, and if the password is right, it will show right. Okay, so I have already opened this binary in the IDA Pro. Now what we will do is directly go into the strings window of the binary, and here you can see the two strings right and wrong, which we just saw when we ran the binary directly. So if we go into the cross references where this string is being used, it is being used with this dialog function, and over here you can see the complete flow of this. Okay, so let's directly jump on to the place where it is asking for the user input. So here we have this Windows API get dialog item text A. This Windows API is responsible for this Windows API is basically responsible for taking the user input from the dialog box and storing that string length into this EAX register. Now we are comparing the length of the input string with hard-coded length 8. So if the input string is of 8 characters, then it will jump on to this code block, otherwise it will jump to this code block. So let's assume that we have let's assume that the user has given the input which is less than 8 characters. In that case, it will move to this code block, and from here you can observe that it is directly going into this code block, and from here it is simply go to this wrong section, but we have to go to right section. So the user input length has to be 8 characters. Now let's move on to the next scenario where the input length is of 8 characters. Then it will come here. From here you can see we have these two hard-coded strings. One is of 8 characters and another one is a very long hard-coded string. Now you can say that or you can assume that this 8 characters hard-coded string can be the correct password. But if you observe the next few instructions, you can see that there is a subroutine which is being called right before the actual comparison of a string, and then um, another subroutine which is actually performing the string comparison character by character. Don't worry if you didn't get it this time. When we look into these two subroutine in detail, you will better understand it. Okay, now these two strings are being pushed onto the stack before call to this subroutine, which means that these two strings are being passed as an argument to this function, and then this function is performing some calculations and returning the manipulated string. So let's look into this particular subroutine. Over here you can see that the strings that the hard-coded strings that are being passed are moved into the ESI and EDI registers respectively. So the ESI register will contain the long hard-coded string, and the EDI register will contain the 8 characters hard-coded string. Okay, now if you look into the next few instructions, you can see that it is performing some manipulations on the string based on the index of the characters. So let's try to understand this by static analysis only. So if we convert this hex value to decimals, so let's first convert all these hex values into decimals. Now what this instruction will do, it is on the first long hard coded string it is adding 42, and then the value present at 42 index will be moved on to AL register. So if we look into our long hard coded string, over here the 42th character we have to look for, and if my indexing is correct, then this capital F will be the 42 character. So this capital F will be moved on to this AL register. AL register is nothing but EAX registers, which is only accessing the lower 8 bytes of the register instead of using the complete 32-bit register. Okay. Then this AL, which is capital F, will be moved on to the EDI, first index of the EDI string. So our EDI string is this hard coded one. So instead of this J, now capital F will come. Okay. Similarly, ESI. So here the first character, 0th index character, will be moved on to AL. So if we look over here, capital I is the 0th character index. This will be moved into AL register, and then this capital I will be moved into the first index of EDI register. So our EDI register is containing this particular string, and at the place of hash, now this capital I will come. Similarly, all these instructions are doing string manipulation based on indexing only. I hope you understood this part. Now let's try to do the same thing using the debugger in order to better understand this flow. So what I am doing here is putting some breakpoints. So let's I am putting one breakpoint at the time of this input call, and then at the time of this subroutine call. Okay. One more thing before going into the dynamic analysis, I want to explain you what this particular subroutine is doing. So what this particular subroutine is doing is basically checking the manipulated string from the previous subroutine, which was 401146. That string will be passed as an argument to this subroutine, and then over here it is comparing character by character in a loop, and if all characters in ESI register matches with EDI register, then our password is right. Okay, so now let's move on to dynamic analysis. Yes, let's run this. Perfect. So now I am putting some random name, QWERT5. Now you can see this is not exactly 8 characters. Let's see what. Okay, sorry. I first need to show you with 8 characters. Now these are 8 characters string. Let's check what happens. We have hit our first breakpoint, which is get allow item. Now the reason why I gave 8 characters as input is because of this where is it? Okay, yeah. So why I gave 8 characters? Because of this comparison. If the input string is 8 characters, then only it will come into this block. So let's see. So as I told you during the static analysis, that this EAX will contain the length of the input string. So the value of EAX is currently 8. Now it will compare 8 with 8, which is correct, so it will jump to this particular code block. Over here we have pushed these two string into the stack. So if you look over here in the stack window, these two strings are pushed over here on the top of the stack, and now this particular subroutine, which is responsible for manipulation of the correct password, will be called. So let's directly come over here. So the ESI will contain the long hard-coded string, and EDI will contain the 8 characters string. Let's see what went into these registers. So if you see, ESI is storing this long string and EDI is storing this 8 characters hard-coded string. Now if we see over here, ESI plus 42, so this capital F is moved on into AL. If you see into A register 46, which stands for capital F, this 46 is ASCII representation in hexadecimal. If you convert this into character, it will be capital F. Now this will, so currently EDI is storing this string, okay, capital J hash K. Now after this instruction is executed, capital F will come at the 0th index of that string. So I executed this instruction, and now if you look over here, instead of capital J, now capital F is present at the 0th index. Okay, let's move on. Next is ESI 0. So at ESI register currently at 0th index we have capital I. This capital I will move on to AL register. Capital I ASCII hex representation is 49. Okay, now this capital I will be moved to this EDI plus 1, which means at the first index of the EDI string. Currently I will show you again, the EDI string is capital F hash, so this hash will be replaced with capital I. Let's see what happened with the DI. So as you can see, instead of hash, capital I is present. Similarly, all these instructions will manipulate something at these particular indexes, and if we look finally, our EAX register will now contain the final correct input string, which is fit geek. So this is the right password we have identified. Okay, now I am not debugging it further and simply executing it. Okay, now if I put fit geek, you can see again I'm not going into the debugging steps and directly executing it, and you can see we got the right dialog box. Okay, so that's how we calculated the, or we found the right password. Okay, now our next task is to patch the binary, and instead of the fit geek string as the right password, I need to put my name. So let's say my name is Lucas. So what I'm supposed to do is, somehow I need to either manipulate this string or this subroutine, or combination of both this string and this subroutine, in order to manipulate the final string as my name. Okay,